Alrighty guys, welcome back to the channel. I am super excited to be bringing y'all this video today of my Atlas Craftsman lathe restoration. My father had this lathe sitting in his back shed. It wasn't getting any use, so we decided to put it back into business with a full restoration. The first thing I did was get online to do some research on these Atlas Craftsman lathes, and I happened upon an awesome community at thehobbyistmachinist.com. These guys helped me identify this lathe and also date it, and this one happens to have been manufactured around 1937. This lathe measures 6 inches from the center of the chuck to the top of the ways, which means that the swing of this lathe is 12 inches. For my purposes as a knife maker, this lathe is the perfect size. After getting the lathe unloaded from the truck, the first thing I did was wire up this aftermarket 1750 RPM motor just to get a little test run in here and make sure everything is working. One thing to notice is that there's a pretty good deal of vibration in the system, and also this arm that has a saddle on it is not in its cradle. And what that means is that I think this belt that goes over the headstock has stretched over time, and instead of changing the belt, what they did was just rely on the weight of the swing arm to keep the belt in tension, opposed to having the saddle resting in the cradle and then adjusting the belt tension by either threading that handle in or out. This will make more sense when we rebuild that section of the lathe. So the first thing that I did here was get some of the easier components off just so I can get my feet wet. You saw that I took apart the steady rest, and here I am taking apart the tailstock. Now throughout this process it becomes apparent that this lathe has obviously not been taken apart in decades. Not only is it filthy, but many of the components are semi-stuck together with either grease or in some cases rust. In this case, on the tailstock, the bottom section of the tailstock is actually 2 pieces, and those set screws you saw me unthreading allows the user to move it either towards the wall or towards the user. So what you'll see in a moment is me getting those 2 pieces apart from each other. They would not come apart with just a soft flow hammer. I ended up using a little bit of spacer material and those threaded pieces of screw just to get this whole thing to start moving to one side, and then it came apart fairly easily. So you can see that this piece of all thread is not long enough on its own. I put in about a 1/2 inch of spacer, and that allowed me to push this bottom piece off. You can see that there was a significant amount of rust there, and that's probably why it was tough to get off. On all these pieces, the first thing I'm doing is getting the grease, the grime, the oil off of them, and getting all that out of the nooks and crannies of these items, and then moving on to stripping the paint. Restoration for Beginners had a great video on the best paint thinner that you can buy at a big box store right now, so I gave that stuff a shot. And I'll say that it worked fairly good at raising the paint off of the pieces. It's not foolproof though. It does still take some time to get all the paint off. The paint itself will plug up your rags and your paper towels fairly quickly. And I ended up using a combination of the paint thinner and a little bit of B12 carb cleaner to get the majority of the paint off. You can see here that it loads up the rag pretty fast before moving on to a larger area of the piece. I've also scraped a lot of the paint off with chisels and with paint scrapers and things of that nature. Once I got the bulk of the paint sprayed off or scraped off, I would move on to a wire wheel to get the rest of the paint off. So here's an example of the stripped steady rest, and then I'm about to show an example of the stripped tailstock. So this was a very time-consuming part of the restoration. I will try hard not to waste y'all's time with showing every piece here, but just know that every piece that has paint on it had to go through this process. As far as the hardware goes, every piece of hardware I ended up taking it to a wire wheel, and I will be showing some of that throughout the course of this build. But the hardware itself was fairly grimy, just like the rest of the lathe, because it's been used since the 30s. So I took each one of those pieces of hardware to a wire wheel mounted on my drill press, just so that I'm dealing with nice, clean hardware. I want to take this time to mention that I'm obviously not a machinist, so some of my terminology during this video may be a little off, and I apologize up front for that. I am learning about lathes through this process. It was actually extremely beneficial to have filmed the disassembly of this lathe, just because reassembling it, I forgot how some things went back together, and I was able to review the teardown tape. So if you're going to be doing a restoration, even if you're not going to post the video of your restoration, it may make sense to video some of your teardown process. So I'm taking this carriage off here, and I notice that the mount for the feed screw has been repaired at one point in time. So these are a common piece to break on these Atlas lathes, especially the Atlas lathes that don't have clutches. That piece is designed to be weak so that it will break before anything bigger does, from my understanding. So it's not surprising that that piece has broken off. The repair on it actually looks pretty good, so I'm going to leave that alone. I'm pretty sure this material is Zamac, which we'll get into later, but it's kind of a cast weaker material than even say like billet aluminum. So we're getting this thing apart. You know, there are a ton of pieces here. What I'm doing for organization is I'll have a box per component. So for instance, the tailstock had its own box, and this carriage will have its own box. And I'm taking old Amazon boxes, cutting the tops off, and turning them into storage containers for this project. One thing to notice here is there was a little bit of rust on these guides, so we're going to get all that nice and cleaned up. The cage that holds this feed gear that you're about to see is made out of Zamac, and it was broken on its third tab. You'll see that in just a moment here. So this is also a very common place to have a breakage on these older Atlas Craftsman lathes. I'll actually be manufacturing a new gear cage there so that I have a nice 3-point connection. Also, I'll be obviously repainting all these pieces, but I made sure to prime and paint the inside of these castings going forward, just because I feel like that's going to reduce rust down the road. What I was just showing y'all there was the section of the carriage that grabs on to the feed screw, and there's a little ball bearing there, and I've almost lost that ball bearing probably 3 or 4 times during this project. So if you have a magnet to put it on or a very nice dedicated box, I would recommend keeping that ball bearing in a safe spot. So this is the wire wheel that I set up on my drill press. This is just a cheap 10-inch Win drill press that I used when I was getting back into knife making, and it worked out perfectly. I used it a ton during this process, and I would highly recommend that setup if you're doing a restoration. I noticed that there were some chips in my tool post slide there. That is also extremely common, especially on a lathe that was used in a school or an environment that you don't have very experienced personnel. They'll run that tool post slide into the spinning chuck, and you'll get big chips there. So as far as a cosmetic fix, I just filled it with a little JB Weld, hoping to round out some of those big chips. So we're going to take a moment here to talk about lubrication of your lathe. The majority of the components on this lathe can be lubricated with ISO 68 or 20 weight oil that is non-detergent. I was able to find some at my local big box store, which I will put a link to below. And I also found some on Amazon, so you can kind of pick your poison. I also purchased some Waze oil. This will be a little bit more tackier of an oil to be used on the ways of your lathe. Both of these oilers really impress me. They're way more robust than the cheap plastic oilers that I have been buying. So I'll put a link to those down below in the description as well. We briefly mentioned this piece when we were taking the carriage apart, but this is the guy that squeezes that feed screw, that feed lead screw there, so that this carriage can be power fed. I cleaned it, and then I decided to reassemble it so that I can store it all as one assembly. One thing to note here is be careful with all these pieces because they are Zamac, and we will get into the definition of what Zamac is later, but just know that it's not the strongest material in the world. And while all these pieces of the carriage are laying out, I decided to get them cleaned up before putting them in their appropriate storage box while I move on to the rest of the project. So I just took a little bit of 600 grit sandpaper here to get off the grit, grime, and rust. Same thing here, I took each of these components apart, sprayed them down with brake cleaner, wiped them down, sanded them down, just so that they're all nice and clean when they go into, I guess, short-term storage in my little cardboard box, so I can put the whole system back together quickly once we're onto that part of the build. When I'm putting these things back together, I made sure to liberally oil everything with 20 weight oil here. So while I'm putting this guy back together, I'll get a little ahead of myself here and go over what ZAMAC is. So ZAMAC is an acronym for a cast alloy. It stands for zinc, aluminum, magnesium, and Kupfer, which is the German word for copper. So this little ZAMAC cage here is broken. And me, not knowing much about the material, figured that, hey, maybe it's worth trying to braze this piece back together. Aluminum brazing rod melts around 700 degrees Fahrenheit, and I found out very quickly that this ZAMAC melts way faster or sooner than the aluminum brazing rod. So that was an epic fail there, and definitely not the way I'm going to end up fixing that piece. But I figured I'd give it a Hail Mary and try it out before going through the process of machining a piece out of aluminum, which I'll be doing later in this build. So this is kind of what I was going over earlier on how I cleaned each piece of the hardware of this lathe. You can see that these pieces were a little gritty and grimy, and this one actually had a little weird amount of yellow paint on that square nut there that was pretty hard to get off. But once all the pieces are nice and clean, and some of them are reassembled, I'll put them in their appropriate box. I removed the chuck here. I didn't show cleaning this guy up, but I ended up wire brushing that guy off really good and getting all the rust off the chuck. Just wasn't very interesting to show in the video here. As I mentioned earlier, this motor did not come with this Atlas lathe in 1937. Someone has replaced the original motor, and in doing so they also cut the motor mount pretty crudely there, so I'm going to be attempting to repair that as well. These belts have seen better days. I don't think that they've been changed out in decades, so we will be remedying that situation as well. So this section of the lathe is probably one of the sections that fought me the hardest to get apart. Not necessarily getting the swing arm off of the lathe, but getting the pulleys off of the swing arm was a massive hassle. If you're going to be attempting a restoration of an old Atlas lathe like this, please realize that these pulleys are also made, I think, out of ZAMAC, and they are very weak. I actually damage the largest of the step pulleys here when I'm trying to hammer the shaft out by not supporting them appropriately. And they dig into the cast iron swing arm, and you can see that chip there on the top of the screen of where I gouged out a little bit of the pulley. This was extremely disappointing at the time, but I guess my lessons learned on messing around with ZAMAC. So I supported the pulley on some 2x4s so that it's not jamming into that piece of cast iron, and I was able to drive out this center rod. The reason why the rod was so hard to come out is over the years a burr was created by the set screws in that pulley. You can note that on this motor mount, the hinge pin has been peened on both sides. I don't know if this was standard from the factory. I'm guessing it probably was. In order to get it off, I ground off one end of the peening and then drove it through. I have a better solution going forward when I rebuild this thing, just to allow me to be able to take that piece off whenever I want to without having to grind off a peen section. So I decided to just round off the corners here that I created by damaging the pulley, just so that there aren't any massive catches or sharp points on that pulley. But like I said, fairly disappointed that I messed up that pulley, and I'm probably going to avoid using that section of the pulley system. To knock down that burr, I used some 320 grit worn belts just to get everything nice and smooth on that shaft. I didn't want to take off a bunch of material, but I did want to knock that burr down so that everything slides together easily. Also on this nut here, it was all gummed up on the entrance and exit of that nut, so I used a countersink to clean all that up. And then I also used a Scotch-Brite belt, and if y'all aren't familiar with these, they're extremely handy to have in your shop. They last a long time, and they can provide a really nice satin finish on metal. I use them a ton in knife making, and they did a really good job at cleaning up some of these pieces. Now what I'm about to do here is probably going to really irritate a bunch of you welding purists. I'm going to attempt to weld cast iron with my flux core wire welder. Now, I'm admitting that this is not the best solution for welding cast iron. However, it is all that I have, and I think that it will make a strong enough connection to suffice for a motor mount. The first thing I did was trace out the broken motor mount and then create some little inserts that I will be welding into it in order to make those holes round-ish again. I'm using some 1/4 inch mild steel here for those inserts. I went back and forth from the grinder to the piece to make sure that these fit into their appropriate locations accurately throughout the grinding process. So once I have them fitting pretty good, I'll go on to welding these guys on. It's my understanding that when welding cast iron, you have to preheat the entire assembly to around, I guess, 400 or 500 degrees Fahrenheit. So I attempted to do that, then tack them on with my wire feed flux core welder, and then dip this whole thing into the vermiculite so that it can cool slowly over the course of the next few hours. From what I understand, the cooling process is the most important part of welding cast iron so that you don't get any major cracks. After a few hours, I took this guy out. I did not see any cracks. I used a Dremel tool to make these holes just a little bit more round, and then an angle grinder to clean up the welds. So like I said, this is definitely not a massive structural strong weld here, but I do think that it is strong enough to mount the motor onto the back of my Atlas Lathe. As a recap, so far we have taken off the tailstock, the steady rest, the carriage, and the swing arm in the back that holds the motor and some of the drive pulleys there. Now we're going to tack the most intimidating part of the teardown, which is the headstock region. I'll be taking off these gears first. These are all, of course, Zamak gears, so be extremely careful with these gears so that you don't drop them accidentally and break a tooth. They are extremely filthy in my case. I think there was some grease applied to these decades ago, and over many heating and cooling cycles and being outside in a shed and things of that nature, this grease is pretty nasty. By using a small pin, I was easily able to knock out the rivets that were holding on the little informational chart there on the inside of this gear cover. I'll be cleaning that guy up and reinstalling it later on in the build after this has been repainted. When taking this thing apart, you need to be extremely careful around these gears. I know I've said it many times now, but you don't want to apply any force directly to this gear. So using a soft blow hammer, I was able to gently knock out this shaft here and get that gear off without damaging it. All of these cast pieces are going to be cleaned, stripped, and painted. Some of the castings were fairly rough on the radiuses. They had some pretty sharp edges, so I took them over to my 2-inch contact wheel and cleaned up those edges. A good deal of penetrating oil, whether it was micro mist or WD-40, was used throughout the process here, just to soak this thing down and make it as easy as possible to get these components off without damaging anything. These are the back gears here. You can see this comes off fairly easily. There are shims on both sides of those castings, and in my scenario with my lathe, I don't think there are enough shims on those castings, and I'm actually going to order some shim stock to space those castings out from the headstock a little further. It is very tight to try to actuate my back gears when the castings are tightened up. This is an eccentric on the outside of the back gears, and I actually had to go online and ask the guys on the forums how to get this thing off. I didn't realize there was a pin there, and I guess the pin had been ground flush with the OD of the eccentric. So once you locate where that pin is, you can drive it out fairly easily and take the back gears apart. Like some of the other shafts on this machine that we've already encountered, there were a good deal of burrs on the shafts that I ended up taking down on my belt sander very gently so that the reassembly process was smoother. To save myself some money in brake cleaner, I started employing a new method to clean the grime off of these castings. I would just use soap, water, and a wire brush to get the majority of it off before attempting to take the paint off. So here I am taking apart the drum switch. This is not the original switch that was on the machine. You can actually see the hole that these wires are going through now was a hole that accommodated a switch. But we have this nice drum switch here that is steel and American made, or I guess it's probably aluminum, but we're going to reuse that switch. This here is kind of a moment of truth. It is the first time I get to check out these Babbitt bearings, and they look pretty good. I was afraid that these could be cracked or shattered, but the Babbitt here on these bearings look pretty good. I did not know going into this project that bearings were ever made out of Babbitt and poured in place, so that's kind of a cool piece of history that I was able to learn during this restoration. Later models of this lathe employed Timken ball bearings, so depending on the age of your lathe, you will either have the older technology of the Babbitt bearings that were poured in place or the Timken ball bearings. Like all the shafts in this machine, I took it to the Scotch-Brite belt to get it cleaned up and smooth. This is a brass plug that I will be putting in behind the set screw here, and what this is going to do is protect the threads on the end of my shaft from being marred by that set screw. So now we're going to take the headstock off of the ways. It is connected by 3 bolts. 2 of them go directly through the ways, and the third one, the largest one, has a little saddle here on the bottom that pushes up against the bottom of the ways. Once all 3 of those were taken off, I was able to lightly tap this headstock off of the ways. Unfortunately, there was a little bit of rust there, but happily it cleaned up fairly nicely. I started to attempt to take off this rail here, which is what your carriage gears use to move to the left and right, and then I realized that there were pins in that rail attaching it to the base, so I decided to leave it alone and to tape it off when I paint it. To get off these nameplates in the back and in the front of the headstock, I used a Dremel tool to cut a slot and then back them off just like screws. I'll be creating my own rivets to put those back on later. This hand impact really came in handy, taking off these bolts that have flathead screw tops on them. I didn't want to put a lot of torque on those, so that knocked them off nicely. Note that the oil cups on the front of your headstock have little felt wicks in them, and those wicks help kind of hold the oil in suspension and also provide a little bit of filtration, I think, for the oil. So I didn't throw those away. I actually cut off the dirty part towards the top and was able to reuse that felt. Using some painter's tape, some earplugs, and some stuffing paper, I was able to tape off all of the machine surfaces and plug up all the holes that I didn't want any paint or primer in. I'll be using Rust-Oleum paint and primer. I'll be using this self-etching primer here. I read that it's better to be used on kind of raw steels, or I guess clean steels, which is what I have with these cast iron pieces that have been stripped. So I get them all nice and primed up, all the components, and then I use some high gloss enamel royal blue paint for my project. From what I understand, the royal blue from Krylon is actually a better match to the original color, but the royal blue from Rust-Oleum was available locally, and I think it was pretty darn close, so that's what I went with. So now we're going to move in to the reassembly of the lathe. First thing I'm going to do is put these feet back onto the ways. I ended up busting 2 of these bolts with their kind of screwdriver heads on them so I replaced those with 1/4-20 hex head bolts. Happily, with this thing being made in America, a lot of the components are 1/4-20, and it's a very easy thing to find in my shop. Using a large piece of granite and a piece of 600 grit sandpaper, I just made sure that the tops of the ways didn't have any big bumps or nicks in them. You can see where I was pointing earlier that the wear on these ways was probably within the first 6 inches away from the chuck, which I think is fairly normal for a machine like this. Considering that this lathe was manufactured in 1937, I feel like the wear is very minimum on this piece. So I got the headstock repositioned. You can see me using the light on my phone to help line up these holes. And then once I had the back 2 bolts on, I gently laid the lathe over so that I can access the bottom saddle here. I did not measure the foot-pounds of torque that I used to reattach that saddle, but I did put a good amount of oomph behind it, considering that this piece will be attached to the lathe and will not be moving. So I got the whole gear assembly back in the headstock. I'm going to be using a 4L-310 belt that you will need to put on at this point in the reassembly process. Otherwise, you will not be able to get that belt on. I found that it was necessary to clean up the machine surfaces on many of these castings after painting, just because here and there was a little bit of paint that got through, and I didn't want any paint in between the surfaces that would be bolted back together. So here's a little insight into the cleaning process and how meticulous it could be. I used a screwdriver with a cloth wrapped around it in order to clean out each individual valley on the gears, just so that I was putting back together a nice clean system. Some of that old grease is pretty hard to get off, and I found that you needed something pretty hard to get in between those gears and clean them out. So I put the back gears back together here, and I created these 2 pins out of stainless. That one obviously was a little too short, but my lathe didn't have any pins in the back gear castings, between the back gear castings, so I made some little pins there to help, I guess, give you some support. So you can see I get this guy put back together. You can see the cradle there for the swing arm, and this goes on fairly well. I do see that it gets pretty tight when you tighten up these castings, so that's why I'll have to add some shim stock down the road. I was carefully putting this assembly back together, and then I realized I needed to move the shaft and gears out of the way. So if you're going to be doing this, make sure you put this little, I guess that's an indicator pin for the indicator spots on that gear. If you're going to be putting that back on, make sure you put it back in first, and then put the gear assembly into the headstock. So those 2 holders I just put on actually end up moving a lot, so I wouldn't worry about those until you've already put this swing arm back onto your machine. I get this, I guess, hinge pin down there put back on and tightened up. Not too tight, that doesn't have to be super tight, it just needs to hold there in one spot, I guess, so it can hinge. I then drive this little nut back in there and attach my swing arm control arm back onto the system. So this is the pin that was peened on both ends. It's the hinge for a motor mount. I originally thought that I would just peen that pin back on there, but I didn't like the way that was turning out, so I decided to drill and tap one end of this pin. By doing so, it allows me to take this off more easily in the future and not peen one side of that pin and mess up my paint any worse than I already had. So I felt like that was a better solution, and we'll see how it works out. So here we're getting all of the brackets for the motor mount put back on. I keep all this nice and loose because when we put the motor back on here, we'll have to move all that around to get the belt tension accurate. I found that this shaft had some pretty marred sections on it and some pretty gummed up sections on those keyways. So I cleaned those up with the Dremel tool and also knocked down the burr on the shaft with my belt grinder. So here I am remounting this 1750 RPM motor back onto the motor mount. I'll be using a new 4L350 belt, and hopefully these new belts and having everything cleaned up will reduce the amount of vibration I was seeing with the initial test run. While I have the lathe turned around, I figured it would be good to snake this wire through the back and connect it to the motor, just because it's going to be easier to do it with the whole thing turned around. Here I'm putting on the hinge bracket for the cover for those gears, and then I'm turning this guy around. You can see that it's a pretty tipsy-turny scenario when you have the motor and a swing arm on this lathe and it's not bolted down. So in order to not have any accidents, I decided to bolt it down to my workstation at this point in time. One thing I found interesting about a Babbitt bearing system like this machine is that they know that these Babbitt bearings will eventually wear. So in order to combat that, they put shims in between the castings. As the Babbitt bearing wears, you will reduce the amount of shims in the castings until you no longer have shims to remove. At that point, I guess you could re-pour your Babbitt bearings and start the whole process over again. I didn't see any excessive play in my Babbitt bearings, so I reinstalled the same amount of shim stock. I then reinserted the clean felt into my oil pots and filled them with ISO 68 20 weight oil. Using some 1/8 of an inch stainless steel pin stock, I made my own little nails here, and these little nails will be holding on my nameplates on the front of the machine and my serial number, which goes onto the back of the machine. These worked fairly well. They were a little finicky at first, and I had to adjust the size and diameter of the little nails, but once I had the diameter correct and the taper right, they held in there pretty good. So here we're going to be reinstalling the gears for my power feed. They were put into an orientation that would feed around I think maybe 4.5 thousandths per revolution, which I feel like is okay. I do want to slow this down in the future, but in order to do so, I will need to acquire some different gears for this system, or maybe buy the tools to cut my own gears down the road. It's always nice to have an excuse to buy new tools. So I get these guys put back into their orientation. I kind of eyeball the spacing. I know that you're supposed to use some cardstock to do that correctly, and I'll probably go back and do that. So this footage here is actually from the future of the build, but I go and I put some high temp grease on these gears in here, just so that I have some nice lubrication that sticks to the gears. The next major part that we'll be working on here is getting it all wired up. I spent about an hour and a half trying to figure out how to get this drum switch to turn this motor forward and reverse, and I thought I had it, but I didn't. So actually my end product ends up turning the motor forward in both orientations of the switch. So I'm definitely not an electrician. I'm just happy I didn't electrocute myself in the process, and it does turn when I turned it on. But I got this guy all wired up. I may revisit that in the future if any of y'all have good ideas on how I can get this motor to reverse. I know I haven't mentioned it yet, but this project took multiple weekends, working many 12-hour days, and working on this a little bit when I got home from work too. So the day that it ran was a pretty darn good day. Now we are going to be manufacturing the cage for our gears that will move our carriage to the left and right. I make a cardstock template first, so I have an idea of where the holes are, and then I go and draw this thing up in CAD, or at least the template for the hole spacing in CAD. I have one piece of aluminum that is the size appropriate for this gear cage, so I only had one go at this project. It took a couple hours to get this thing cut out. My poor bandsaw was really put to work, just because when you're cutting something this thick, it takes a long time. I think you guys are really going to get a kick out of this piece because I messed up multiple times, and while it's probably not as strong as it would have been if I did it right the first time, I think it's strong enough for the application that it will be used in. The first and most critical mistake that I made was gluing the template onto the piece with the ink facing up and then drilling those holes from the top. In reality, I should have flipped the template upside down and then drilled those holes. You will see here when I go to put it on its eventual home, it's backwards. So at this moment, I kind of freaked out because this was the only piece of aluminum I had. I wasn't very happy, but I found a solution that was a little outside the box. I cut off the face of this thing, and then I planned to braze the box section onto it. Considering that this is the first time that I ever brazed aluminum, this went fairly well. I was able to get the two pieces connected to each other. I then used a fly cutter to flatten the back of this plate. You may be able to notice that there is a slight bend in the back of this plate because when I was brazing it, I had it clamped down to the table so hard that the heat actually bent the aluminum a little bit. So I was running into problems left and right with the manufacturing of this piece. But eventually I was able to get it to bolt up to the carriage. So this was step one. The next step is going to be to put a 1/2 inch hole through the center of this guy, and this is what the gear shaft will go through. So I drill my 1/2 inch hole through the center, and then I relieve a little bit of space here on the back of the piece that will be going up against the carriage so that that gear has some space. You can see I have some gaps on the inside there, and I thought about brazing those gaps, and when I did, I heated up the brazing on the outside of this piece and it actually came off. So instead of attempting to braze that piece back on, I decided to use some 2-part epoxy and some hardened 1/16 of an inch dowel pins to attach this piece back onto the assembly. I feel like with the dowel pins in there and the JB weld, this is going to be a fairly strong solution, or at least strong enough to be used in this application. But time will tell, and if it breaks, I will buy a piece of aluminum and do it the right way. You can see that the last component of this cage was to put a 3/4 of an inch hole through the entire cage. That is for the lead screw to go through, or I guess the feed screw. I did that by hand. I would recommend drilling that hole first if I was doing this again. Now that my gear cage has been made, I go ahead and install it onto the carriage, oil it up, and start putting together the rest of the carriage. I get this assembly here put back on. I later realized that it's in the way, so that is not a component that you want to put on first. I actually run into that when I'm putting on these guides that go under the gear cage and the I guess that's the feed screw engager. I also noticed that when I took it off, I had it upside down, so it was a blessing in disguise. That ball bearing actually lines up with a hole on the bottom of the casting of the carriage. Now, I will note that I think there's supposed to be a spring on the other side of that ball bearing that I will have to add to the system later, since I did not have a spring when I tore this system down. But that being said, this actually works fairly well once I have it all on there, and I'm not sure if that spring is necessary. This was another moment of truth here. I was able to get the whole assembly back onto the lathe, and I was able to move the carriage back and forth with my new gearbox. So I was pretty happy at this point in the process. Right here I am reinstalling the carriage stop and the thread indexer. Next we're going to install the swivel and the cross slide and the rest of those components. So I get all the tape off and then oil the heck out of this thing. One thing's for sure, my lathe will not be lacking in the amount of oil that is on it. It will be a well-oiled 1937 Atlas Craftsman lathe for sure. So we're putting on the swivel piece here. You notice that the nut that this screw goes through is brass, so I wanted to be very careful with it. I gently put in the gibs and lined them up with the set screws so that I can adjust, I guess, the side-to-side wobble of this piece and dial it in so it's nice and tight, but not so tight that it won't move. You can see that these inserts are made to dovetail up against this centerpiece here so that it's not marred by, say, just a straight set screw. So I put those in first and gently pushed them up against the dovetailed section and then run in these set screws. Unfortunately, I'm going to have to take this part back off in order to put that brass nut on the bottom here. So once I get that brass nut on there, I put the whole assembly back together and snug up the set screws to hold it all in place while I put this cross slide on here. Now that the tool post slide is mounted onto the swivel, I can put the gibs in there, tighten those down snugly so that I don't have any wobble, and then screw in the handle of the tool post slide and reconnect it. So the carriage section is now complete. We're going to move on to the tailstock. So as you remember, these two pieces were fairly difficult to get apart initially, but they went together way easier now that everything's been cleaned and oiled up. I put this, I guess you'd call this a gib as well, onto the bottom of this piece, and those tapered screws on both sides will push that into the ways and tighten up any wobble that you'll have on this tailstock. Here I am reinstalling the lock for the ram. I made sure to install this lightly so I can still get the ram to pass into the casting for the tailstock. I make sure to screw in that large screw there into the ram before installing the ram so that I can put the handle onto the end. And that's pretty much it for this. I did shorten one of those headless set screws there just because it was kind of nasty sticking out as far as it was. And then I refilled up that pot there. That's actually a dauber for using a dead center, so you can put oil on your dead center. I thought that was kind of a neat little blast from the past. So now that we've completed the restoration of this lathe, we will be installing a small upgrade, which is an AXA quick change tool post holder. And this was probably the largest recommendation I got for cool add-ons to your lathe. I will be putting a link to this exact tool post holder in the description below for your convenience. The only modification that you need to make to this is to machine this nut that will go into your cross slide. It's just machining out a little shoulder on both ends of the nut and cutting down its total size so that it will fit into your cross slide. So previously, as you saw, I put the dimensions that you will need to machine this piece to. It is a very simple milling operation, and it allows you to screw this quick change tool post onto your 1930s Atlas lathe. The nice thing about these guys is that you can get your tooling adjusted to the appropriate height and then screw that locking nut down so that you can just take these in and out easily without having to readjust the height. So I can see myself buying a lot more of these holders just to speed up specific processes, but I was pretty impressed with the build quality of this piece, and we'll see how it holds up over time. Alrighty, so here are some before and after pictures of this lathe restoration, and overall I think it turned out pretty darn good. You know, I think the thing that I liked the most about this project was that I was resurrecting an old piece of vintage machinery back into working order. It was like a phoenix rising from the ashes, and now, you know, this lathe will be used in my shop for years to come, and there will be plenty of handmade custom knives that this machine will help me make. So I thought it was really cool to bring a piece of the 1930s back into the 21st century, and I'm going to be using it probably, you know, weekly going forward. So I thought that was a really cool part of this process. It was really fun to do. I learned a ton about these lathes and how they work, and I would recommend anyone who gets their hands on a vintage piece of equipment like this to spend the time to take it apart and then make it look good and make it function well going forward. It's also worth noting that in these running shots here, you can see there is much less vibration in the system, and that is because I have new belts and the saddle of the swing arm is riding in the carriage. So I was very happy to see that reduced the vibration significantly. So I really hope you guys liked this video. If you did, hit that like button down below and consider subscribing to the channel. Also, please let me know in the comments if there's anything that you thought I could have done better or anything that you'd like to see in the future. With that, I'll catch y'all on the flip side.